Okay, I decided I'm just going to kind of go through these. So if you want to watch this before the test, you can. So number 1 says sand is deposited into a pile with a circular base. The volume V of the pile is given by V equals R cubed over 3, where R is the radius of the base. The circumference of the base is increasing at a constant rate of 5 pi feet per hour. When the circumference is 8 pi feet, what is the rate of change of the volume of the pile in cubic feet per hour? So we're trying to find dV over dt. So again, kind of think about what we're looking for. We're looking for dV over dt. So if we take the derivative of this, that would be 3r squared over 3 times dr over dt. So the 3's cancel. But what's missing in this problem is the radius. So they give us that the circumference is increasing at a constant rate. So circumference, a circle circumference is 2 pi r, right? And they give us that the dc over dt is 5 pi feet per hour. And they tell us when the circumference is 8 pi feet. So I think we can use that to find our radius, right? So if the circumference is 8 pi equals 2 pi r, I get that r equals 4, so that's helpful. I also need dr over dt, so if I take the derivative of this and get dc over dt equals 2 pi dr over dt, and the circumference is increasing at 5 pi. Oh, I hate that my smartboard never works good at the end of the day. And I divide by 2 pi, I get that dr over dt is 5 halves. The radius is 4. So I think I could plug in over here now that dv over dt is 4 squared times 5 halves, or 16. That would be 16 times 5 halves, which would be 40 as my answer there. But again, a lot of like in-between steps there to get that. It'd be hard to just guess that, I feel. All right, look at number 2. Number 2 has e's and y's and x's, and so that's an implicit, and it says at x equals 1/2 and y equals 2, find dy over dx. So step 1 is I'm going to take the derivative with respect to x. So when I do e to the, remember that the derivative of e to the u is e to the u times u prime. So the derivative of that would be e to the xy, and then the derivative of that would be the product rule. So that would be y plus x times dy over dx. And then on the other side, the derivative of e is just a number if there's no x there. So the other side is just 0 there. So I don't know. Do we want to sub in or not sub in yet? If I was going to not sub in yet, I would have just left this as y plus x dy over dx equals, oh no, that's 0. Okay, yeah, I'm gonna sub in what I know. X is 1/2 and y is 2, so that would be 1/2 times 2, and then 2 plus 1/2 dy dx. So that would be just e, so 2e plus 1/2 e dy dx equals 0. So if I get dy dx by itself, I'm going to get 1/2 e dy dx equals negative 2e. So subtract that over, and I could even write this, instead of 1/2 e, I could write this as e over 2. So I could go 2 over e. I feel like I did something wrong because this seems like it's not so bad to do. I would get negative, oh, that didn't work. Oh my gosh, I forgot my y squared. I just left that out. Okay, sorry. I hope you caught that. Goodness gracious. I was like, none of these are the right answer. I was so excited about this, I forgot minus y squared. So that would be minus 2y dy dx equals 0. Good gravy. This is the kind of stuff I do on the real test. So, I don't know. Do you want to sub in or do you want to not sub in? Because we could totally get it by itself first and then sub in. Like we could distribute and get y e to the xy plus e to the xy x dy dx minus 2y dy dx equals 0. So if I subtract this over and factor the dy dx out, I would have e to the xy x minus 2y equals negative y e to the xy. So I think before subbing in, sorry about that craziness, I would get negative y e to the xy over e to the xy x minus 2y. And now I would plug everything in. And I would get negative 2e, because 1/2 and 2 cancel out, over 1/2, because that's the x, e, minus 4. And then you're like, well, none of those are the answers. Well, that's because it's a fraction and a fraction. So we could get a common denominator. I don't know. I would just multiply the top and the bottom by 2 here if it was me. So then I would get negative 4e over e minus 8. So C, do you agree with that? It's the exact opposite. If I like took the negative out of the top and moved it down to the bottom, if I took that negative and moved it down to the bottom, it would make the 8 minus e on the bottom. So C is the right answer. Oh my gosh, that was crazy. All right, number 3. Okay, maybe I'll do better on this one. This one just is in terms of x and y. So that would just be 3y squared dy dx plus dy dx equals 2x. So if you factor that out, you would get 3y squared plus 1 and divide it over. So 2x over 3y squared plus 1. Oh man, I've redeemed myself maybe. Look at the next one. It says the top of a 15-foot long ladder rests against a vertical wall with the bottom of the ladder on level ground as shown below. The ladder is sliding down a wall at a constant rate of 2 feet per second. So this is going down. So again, if we call this y, I could say right now that dy over dt equals negative 2 feet per second because it's falling down. It says in what rate in radians per second is the acute angle between the bottom of the ladder and the ground. So we're talking about this angle down here. At the instant, the bottom of the ladder is 9 feet from the base of the wall. So the moment that, if this is x, that x is 9, we know this is 15. So just like the one that we did, we can set up a problem here, but we know the rate of y. So I think that we want to have dy over dt in the problem. So I think we want to set up sine here. Sine of theta would equal y over 15. So when I take my derivative, I get cosine of theta times d theta over dt equals 1/15 times dy over dt. And the cosine, we know this is 9, so the cosine of theta is 9 over 15. We're looking for d theta over dt. And we know that dy over dt is negative 2. So just like the one that we did in class the other day, we can multiply by the reciprocal here times 15 over 9, and the 15s cancel. So I think that I get negative 2 over 9 radians per second as my answer there. So use the trig function that you have the rate that you're looking for so you don't have to do like a secondary problem. Okay, look at 5. It says, which of the following is an equation of the line tangent to the graph at this point? So this is another implicit problem. Step 1, I think, would be find the derivative, and then we could go from there. all the slopes are different. So again, this is a product rule. So that would be 2x minus 3y minus 3x dy dx, because the derivative of y is dy dx. And then remember to put a 0 over there, not a 10. So dy dx, if I subtract this over, that's negative 2x. I would add this over, that would be plus 3y. And then I would divide by the negative 3x. And then I'm going to plug in this point. So negative 2 times 1 is negative 2, minus 9, because negative 3 times 3, over negative 3 times 1. So negative 11 over negative 3 is positive 11 over 3. Lots of room for negative errors there, but still be able to write tangent lines, but we can do it with implicit. Look at this one, implicit with ln. Remember the derivative of ln of u is u prime over u. So if we were going to do the derivative of this, on the bottom we would just 2x plus y, but on the top we'd have 2 plus dy over dx. And then on this side we would have just equals 1. And then I could multiply this over here, right? So I'd get 2 plus dy dx equals 2x plus y. And then I just subtract 2 over. That seemed not so bad, right? Maybe just a reminder of ln. So B should be the right answer. Number 7. How many of these are there? 11. Number 7 says the volume of a sphere is decreasing at a constant rate of 3 cubic centimeters per second. At the instant when the radius of the sphere is decreasing at a rate of 0.25 centimeters per second, what is the radius of the sphere? And again, they give us this, right? So they give me dv over dt is decreasing, so that's negative 3 cubic centimeters per second. And they give me dr over dt is 0.25 centimeters per second. It says, what is the radius? So I think if we just take the derivative of this, we would get 4/3 pi, and then times 3r squared dr over dt. The 3's cancel, and I could plug my numbers in. Negative 3 equals, dr over dt is 0.25. You could say, I'm going to say 1/4, okay? Because I'd have 4 pi r squared times 1/4. So really nice, the 4's cancel out. And I could divide by pi here. And to get my, that's what r squared would equal, negative 3 over pi. So then I would take the square root of that. And since it gave me decimal answers, I'm assuming that this is a calculator question, yes? And if I take the square root of, well, why do I have a negative number is the real question. Because it shouldn't be negative, right? Oh, because this is also decreasing, right? That's supposed to be negative 1/4, so the negatives cancel out. And if you do that on your calculator, you get E. And that's one of those that I messed up a negative, but none of the answers were negative, so it saved my butt there, right? Number 8 says find this, which remember is the second derivative. Thank goodness on this, they've already kind of given us the first derivative. So if all we have to do is move that over and say that's 2x minus y over x plus 2y. The other thing that's nice on this one is they gave us a point, so we don't even really have to simplify it. We can just plug our numbers in, but it's a lot of room for error, okay? So this is a quotient rule here. So if I do the derivative of the top, that would be 2 minus dy over dx times the bottom, which is x plus 2y, minus the derivative of the bottom would be 1 plus 2 dy dx, times the top, which is 2x minus y, all over the denominator squared. And so remember that we can replace dy dx with this, But I also would say, I think in this problem, I'm going to go ahead and plug in what is dy dx equal when I plug in the 0.30. So that would be 3 times 2, or 6 minus 0 over 3, which would be 2. Do you agree with that? So that's helpful. So the derivative is 2 here, instead of plugging in all these x's and y's. So now if I'm trying to do this, I can say 2 minus 2, because that's the derivative, and then x is 3 plus 0 minus 1 plus 2 times 2, so 1 plus 4 times 6 minus 0 over 3 squared, which is 9. So this is nice because it's all 0. So 5 times 6 is negative 30 over 9, which will reduce to negative 10 over 3. Thank goodness I got one of those answers, right? Again, lots of room for error on that. This one is like one of the ones we did in the practice again. It says a person whose height is 6 feet is walking away from the base of a streetlight along a straight path at a rate of 4 feet per second. If the height of the streetlight is 15 feet, what is the rate at which the person's shadow is lengthening? So in this one, we did one where I was walking towards it, right? This person is walking away, so this is 6 feet. He's walking away from the streetlight this time, so he's going this way at a rate. So let's see, if we call this, I don't know what we want to call it. If we call this x, we could say dx over dt is 4 feet per second. The height of the streetlight is 15 feet. It said, what is the rate that his shadow is lengthening? I'm going to call this S for shadow. So again, I know how to do this because I've done it before, that I'm going to kind of set up a big triangle here where this is the side together is x plus s. And I'm going to compare that to a little triangle right here. And it's kind of up to you on how you want to do it. If you want to compare like this side to this side, we could say 15 over 6 equals, this is the big side, so that would be x plus s over just s. And we can, I don't know, cross multiply here and say 15s equals 6x plus 6s. And if you want to subtract that over, you get 9s equals 6x. And you could even divide by 3 here to make your numbers smaller. 3s equals 2x. That we could take the derivative here and say, I'm not going to be done anytime soon, Mr. Franz. Sorry. ds over dt equals 2 times dx over dt. And I know, I'm trying to find this, right? But I know this. So I can say 3 times ds over dt equals 2 times 4. Divide by 3. So I get 8 over 3. Or what is that, 2 2/3? I know that's a crazy problem. I only can do it so well now because I practiced it. So maybe you should practice it as well. Okay, 2 more. Number 10 says, an ice sculpture in the form of a sphere melts in such a way that it maintains a spherical shape. That doesn't seem likely. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. At what rate in square meters per hour is the surface area of the sphere decreasing at the moment when the radius is 5 meters? Note, for a sphere of radius r, the surface area is 4 pi r squared and the volume is 4/3 pi r cubed. So they give us the volume, so they give us dv over dt is negative 2 pi cubic meters per hour. At what rate is the surface area decreasing? So I'm looking for dA over dt is what I'm looking for. So if I take the derivative of the surface area, I get dA over dt equals 8 pi r dr over dt. But I'm guessing I'm missing something, right? The volume, at what rate, the moment the radius is 5. So I know the radius is 5. What I don't know is dr over dt. So that's where I'm going to use the volume equation here, just like that first one, to kind of do some in-between stuff. And I get dv over dt equals 4/3 pi times 3r squared dr over dt. So 3's cancel. I know that this is negative 2 pi, and I get 4 pi. The radius is what? 5 squared dr over dt. So I can divide here by 25 times 4 is 100 pi. So the pi's cancel, and I get negative 1 over 50. It's melting, so that makes sense that it's a negative number, yes? So let's see if that works. So if I plug that in now over here for dA over dt, I get 8 pi times r, which is 5, times negative 1 over 50. So that would go down to 10. So what is that? Negative 8 pi over 10, which reduces to negative 4 pi over 5. Uh-oh, I have too many negatives. Oh, it just says at what rate is it decreasing? And so since it already says it's decreasing, that's why we don't need to put the negative on it, right? We don't say decreasing at a negative rate. It already said it was decreasing. So that's why A is the right answer. Okay, last one. It says a hemispherical water tank, not a conical one, shown above has a radius of 6 meters and is losing water. The area of the surface of the water is A equals 12 pi h minus pi h square meters, where h is the depth in meters. When h is 3 meters, the depth of the water is decreasing at a rate of 1/2 meter per minute. At that instance, what is the area of the water surface is decreasing with respect to time? Good gravy. So that's a lot of words, but they tell us the area of the surface is this, and they ask us to find the rate at which that's changing. So we're looking for dA over dt. So if I just take the derivative of that, I would get 12 pi dH over dt minus, and remember pi is a constant, so that just becomes 2 pi h dH over dt. And we could simplify this a little bit if you want, but I think we can just plug numbers in because they give me what? They give me the height is 3, and they give me dH over dt. Be careful on this, though. It's decreasing, right? So that should be negative 1/2. So if I plug that in, I would get negative 1/2 minus 2 pi, and h is 3, again, times negative 1/2. So that becomes negative 6 pi plus 3 pi, which I get an answer of negative 3 pi. But again, it says at what instance is the area of the water surface decreasing? So we already know it's decreasing, so that's why we just pick A as the right answer. Okay, so Monday we're going to do the multiple choice part of the test. If you look at the next page, this has some more practice with related rates. The answers are there, so try to set it up, see if you can get there, and then we can go from there.